One really important calculus problem, perhaps maybe the most important calculus question of Calculus 1, is how do we find the slope of a tangent line to a function at a specific x value? So what does that even look like, first of all? So here I've got this function f of x that would be given to you. I've identified one particular x value that I'd like to talk about here, x equals a. What the tangent line to this function at that point is going to look like, it's going to intersect the function at that particular x value, and it's just going to graze the function at that one point. It should share the same slope, sort of the same curvature of our function at that one particular x value. And that's what the tangent line looks like. So this red line that I've drawn here is the tangent line to our function f of x at x equals a. And I want to know, well, how do we find the slope of this line? And can we kind of generalize that process so that we could do it with a lot of different functions and a lot of different x values? It turns out that's a really hard process to do. That's a very difficult question to answer. So we're going to take a step back and we're going to start with a question that's a little bit easier. We're going to start with, well, what do we know? So instead, we're going to take a step backwards to talk about the slope of the secant line. So the slope of the secant line from x equals a to x equals b is given by this formula right here, f of b minus f of a over b minus a. This is also the same thing as average rate of change. You might also recognize that as the slope formula. You might recognize that as y2 minus y1 over x2 minus x1. What the secant line would look like, so let's pretend we have a similar function right here. Here's f of x. I'm going to identify two different x values this time. So perhaps I'll say right here we'll have x equals a, and then right here we'll have x equals b. And I want to basically connect the dots of my function between those 2 points. So I'm going to connect those 2 points with a line. And that's what the secant line would look like. The red line that I've drawn right here is the secant line. Now, this is something we know how to do because really what we're doing is just finding the slope of this line. This point right here is a comma f of a. And this point right here is b comma f of b. And we're just using the slope formula on those 2 points. So we're saying, okay, the slope of that red line is f of b minus f of a divided by b minus a. So this is something that we're more familiar with, something that we know how to do. In the next video, I'm going to show us how we can take this average rate of change, this slope of the secant line, and combine it with the limits that we've been talking about here in the beginning of Chapter 2 to see if we can come up with an approximation, see if we can build our way towards the slope of the tangent line, because that tells us all sorts of interesting calculus stuff.